but to treat each Planck cell as housing a geometric complex. Let's just call it a complex. So some geometric object in here with its own symmetry group uh, and graph structure, and where each has a configuration, a combinatorial configuration, and you look at the symmetry group, the action of the symmetry group of each one. It can be in concert with one another. It's sort of maybe like some dynamics going on, but this one shifts in some sort of configuration, which cascades to that one, which cascades to that one, and essentially, I think these dynamics are really like the temporal, or sort of like entropy or time, and that if everything's static, the configurations are all static, then you basically have just space at a given moment in time. So in that way, I think time emerges is sort of emergent from the interactions of the inside of the objects inside the Planck cells. So on the graphs, the edges are colored, different colors. You can put a line bundle. So you get a holonomy bundle, and the delta action. The delta actions are elements of the internal symmetry group. And this is just a cross section of the cube, one cube right there. But anyway, the delta actions, these are elements of the internal symmetry group. Basically, you slice, you permute, attach back, etc., etc. You can compose them. It forms a non-commutative algebra. You get a non-commutative geometry as a result. And what's interesting is that the vectors on the line bundle, so you can look at fixed points of the holonomy group under, iterations of compositions of or strings of delta actions, and that is cool because you can also look at the holonomy twisted Ihara zeta function on each of these graphs. So they're very coupled to one another, but you can sort of distinguish and tease out